Hey there. In this video, we are going to talk about something called variation. We're going to begin with direct variation. So there's a couple ways to say this, but one of them is if y varies directly with x, so direct variation, if y varies directly with x, the relationship can be written like this. Y equals k, some number k, times x, where k is called the constant of variation. We're going to be given some information and we're going to try to find out what that constant of variation is for different scenarios. Another way to say that y varies directly with x is you can say y is proportional to x. So you need to recognize both of those sayings, and if you see y is proportional to x, again, it means y is going to equal some number k times x. So let's look at some verbal phrases and then what their equation looks like. Y varies directly with x. We'll look, get rid of that. If y varies directly with x, then y equals k times x. So when you see that, immediately write that equation down. You can have different letters involved, so instead of y, it might be m varies directly with the square of t. So think about what the square of t would look like, and we would write it like this. M is equal to, there's my constant of variation, but instead of m equals k times t, we're going to say m equals k times t squared, because that is how you write the square of t. Another example, y is directly proportional, remember that means the same thing as direct variation, to the cube of w. This is a page number, don't worry about that, 7. So y equals k times the cube of w is w cubed. So you have to pay attention to the words that are being used. Oops, that is number 4. Okay, so here's an example of what you're going to need to know and be able to do. You see this equation, let y vary directly with x. Right away, you're going to write y equals k times x. And then we're told that if y is 15 when x is 5, find y when x is 7. So the first thing we want to do is we want to find that constant of variation. So when y is 15, so I'm going to substitute in 15 for y, and I don't know what k is yet, but I know that when y is 15, or if y is 15 when x is 5, so I'm going to substitute in, I'm putting 5 in place of that x. Now we're going to solve for k, and that's simply just divide by 5 on both sides, and we get 3 is equal to k. So now we have our equation, y equals 3 times x. So for this scenario, the value of k, the constant of variation, is 3. And we found that out from the given information. And then based on that information, we're going to now use our equation and find y when x equals 7. So we're going to substitute in 7 for x, and we get 3 times 7, which is 21. So the answer to the question is y equals 21 when x equals 7. Okay, the second part of this lesson is something called inverse variation. And so it's similar to direct variation. We can also say y varies inversely with x, or we can say y is inversely proportional to x. But as soon as you see that inversely, this is how you're going to write the equation. It's going to be, instead of k times x, k divided by x. Now k, again, is a constant. We're going to figure it out based on the scenario what k is, and y and x are going to be variables. So to write this next one, s varies inversely with the square root of t. It's going to be s equals k divided by the square root of t. And then this last one here, y varies inversely with the square of x. So be careful between square and square root. Try to write this out and see if you get it right. So y is equal to k with the square of x, k divided by x squared, because it's divided because of that inversely there. All right, so Here's an inverse variation example. The volume of gas is inversely proportional to the pressure of the gas on its container. So here, if we have, so it's inversely proportional. So let's let V equal the volume and P equal the pressure. So if you're not given variables, you need to make some variables up. And so the volume of gas is inversely proportional to the pressure of the gas on this container. So let's write this equation. The volume of gas is inversely proportional to the pressure. So we're going to go V equals K over P, where V is the volume, P is pressure. So now if we have a 48 pounds per square inch pressure corresponding to a volume of 50 cubic feet, what pressure is needed to produce a volume of 100 cubic feet? So, we know that when the pressure is 48, the volume is 50, so we can now solve for K. So I'm going to have, in place of V, I'm going to put 50. So I have 50 is equal to K, so I'm just plugging in the V and the P, divided by the pressure. And that's because they're inversely proportional. So to solve for K, in this case, I need to multiply both sides by 48. So 48 times 50, and a quick way to do that is if you do 48 times 100, you get 4,800, but we're only multiplying by half that amount, 50, so cut that in half. K would be 22,400. So then we know what K is, and K is we're going to write the equation with plugging in that value of K that we just found. So now we know our relationship between volume and pressure. Leave V and P as variables because as the pressure changes, the volume is going to change. So those are going to stay as variables until we are wanting to find something like this. Now find the pressure when the volume is 100. So we're going to put in 100 for V, and we're going to solve this for P. So there's a lot of different ways you can solve this equation. I'm going to go through the methodical way. You could put this over 1. You could do cross multiplication. There's lots of different methods, but I'm going to go like this since what I'm solving for is P and it's in the denominator. You never want what you're solving for to be in the denominator. So what I'm going to do is I'm going to multiply both sides by P. On this side it cancels out. So now rearranging that, 100P equals 2,400. Oops, my smartboard is not keeping up with me. And then now I have 100 times P equals 2,400. So now I want to divide by 100 on both sides, and I get P is equal to, and we can just cross those zeros out, P is equal to 24, and it'll be the same units, pounds per square inch, that we were given in the initial problem. Okay, so let's see. The third part here, part C, is on something called joint variation and other combinations of variations. So let's look at some verbal phrases. If y varies jointly with x and z, that means it varies directly with both x and z. So we'd write our equation like this. Y equals k, instead of just k times x, it's going to be k times x and z. And k is going to end up being a number. That's our constant of variation. But here x and z and y are all going to be variables. Okay, the next one, t varies jointly with r and the square of s. So you try to write that one out, pause the video, and check your work. It's going to be y equals k times r times s squared. Again, r, s, and t are all variables. K is going to be a number based on the scenario that we're given. And then this last one, v is directly proportional to t, and inversely proportional to the square root of p. So v is directly proportional to t. That means we're going to go v equals k times t, because direct is multiplication, but it's inversely proportional to the square root of p. That equation would look like that. All right, so that is, we could do an example. Let's say that y varies jointly with x and w. So write that equation, and let's say that y equals 40 when x equals 5 and w equals 6, we'll say. So this is the type of problem you might get. And then you might be told to find y when x equals 12 and w equals 15. So we're going to start out by writing this equation that y varies jointly with x and w. So y equals k times x times w. Now we need to find k based on the fact that when y is 40, so I'm going to plug in 40, I'm going to go over here. 40 equals k times x. It equals 40 when x is 5 and w is 6. So we're going to go 5 times 6. So then I have 40 is equal to 5 times 6 is 30, and I'm going to put 30k like that. Solving for k, we get, if we divide by 30 and solve for k, k is equal to 4/3. So then writing out the equation, we have y equals 4/3 times x times w. And now we're supposed to find y when x is 12 and w is 15 with this value of k. So we're going to go y, you guys figure it out and then come back and check it. I'm going to go y equals 4/3 times 12 times 15, and I'm going to throw that into a calculator. And I get that y is 240. Okay, so that is basically 8-6 in a nutshell. Bring your questions to class on Monday night, and I will see you there.